expression which is there in the bracket we want to express as cos, so that we can make use of the property cos inverse of cos x is equal to x. Here we observe that 3 upon 5 whole square plus 4 upon 5 whole square is equal to 1 square. So it satisfies Pythagoras theorem. So we can consider this Pythagorean triplet. And now we will replace 3 by 5 with a cos or sine, right? So in this case we want to have cos inverse of cos, and formula for cos a plus b or cos a minus b is cos sine, right? It can be cos a cos b plus sin a sin b or cos a cos b minus sin a sin b, but here it is plus, so it will be formula for cos a minus b. So we will replace, let 3 by 5 is equal to cos theta and 4 by 5 is equal to sin theta. So we get LHS is equal to, therefore LHS is equal to cos inverse of 3 by 5 we are writing as cos theta. So cos theta into cos x plus sin theta into sin x. This is equal to cos inverse of, we prefer writing x term first. So cos x cos theta plus sin x sin theta. That is equal to cos inverse of cos x minus theta equal to x minus theta. But what is theta? So x minus, what is theta here? Now cos theta sin theta we know, so we can say that since tan theta is equal to, what will be value of tan theta? 4 upon 3. So theta will be tan inverse of 4 by 3. That's what we wanted to prove. So this is equal to the RHS. So LHS is equal to RHS. Let's proceed with the next one. Prove that 9 pi upon 8 minus 9 upon 4 sin inverse 1 by 3 is equal to 9 by 4 into sin inverse of 2 root 2 upon 3. This problem is from the textbook, but there is a printing error, so I have corrected that error. Now let's consider LHS. LHS is equal to, you can easily remove 9 upon 4, right? So 9 by 4 common. So inside the bracket what remains is pi by 2 minus sin inverse of 1 by 3. This is equal to, I am going to replace this term which is inside the bracket with cos inverse of 1 by 3. I hope it is clear. Since sin inverse of x plus cos inverse of x is equal to pi by 2. So sin inverse of 1 by 3 plus cos inverse of 1 by 3 is pi by 2. Sin inverse 1 by 3 plus cos inverse 1 by 3 is pi by 2. Therefore, pi by 2 minus sin inverse 1 by 3 is cos inverse of 1 by 3. Fine. Further, how do you proceed? Our right hand side is 9 by 4 sin inverse of 2 root 2 by 3. That means we will have to write this term in, instead of cos inverse we want to have sin inverse term. Now cos inverse, so 9 by 4, this we want to convert. Now if we consider cos inverse of 1 by 3 is theta, will imply cos theta is equal to 1 by 3. So use trigonometric identity or use Pythagorean triplet. Cos theta, suppose this angle is theta, cos theta is 1 by 3. So this side will be 9 minus 1, that is 8. Square root of 8 means 2 root 2. So sine theta will be 2 root 2 upon 3. Therefore, I can replace cos inverse of 1 by 3 with sine inverse of 2 root 2 upon 3. That is equal to the right hand side. Next, prove that sine inverse of x is equal to cos inverse of root 1 minus x square is equal to tan inverse of x upon root 1 minus x square is equal to cot inverse of root 1 minus x square upon x is equal to sec inverse of 1 upon root 1 minus x square is equal to cosec inverse of 1 by x. So we want to prove all this. Let's start. Let sine inverse x is equal to theta. Okay, what we have assumed, theta is sine inverse of x. Okay, so our theta is sine inverse of x. Now sine inverse x is theta, therefore we can say x is equal to sine theta. Now if you know x sine theta, you can easily find cos theta. Therefore cos theta, which is equal to square root of 1 minus sine square theta, will be square root of 1 minus x square. So theta will be cos inverse of root 1 minus x square. Fine. Now we know sine theta, we know cos theta. So tan theta is equal to sine theta upon cos theta is equal to sine theta is x, cos theta is root 1 minus x square. Therefore theta is equal to tan inverse of x upon root 1 minus x square. Now remaining three ratios we can easily find. Cot theta is equal to, or you can make use of the properties. Cot theta is equal to 1 upon tan theta. So you'll have root 1 minus x square upon x. Therefore theta is equal to cot inverse of root 1 minus x square upon x. Then sec theta, as we know sec theta is 1 upon cos theta. So we get 1 upon root 1 minus x square. Therefore theta is equal to sec inverse of 1 upon root 1 minus x square. And cosec theta is equal to 1 by sine theta. So this will be 1 by x. So you'll have theta is equal to cosec inverse of 1 by x. So theta is equal to all this. Therefore we got sine inverse x is equal to cos inverse of root 1 minus x square is tan inverse of x upon root 1 minus x square is cot inverse root 1 minus x square upon x is same as sec inverse of 1 upon root 1 minus x square is same as cosec inverse of 1 by x. Let's proceed with the next one. For the next one we are given if cos inverse x plus cos inverse of y plus cos inverse of z is equal to pi, then prove that x square plus y square plus z square plus 2 times x, y, z is equal to 1. So here we are given cos inverse x plus cos inverse y plus cos inverse z is equal to pi. Therefore, we can say cos inverse x plus cos inverse y is equal to pi minus cos inverse of z. So, cos inverse x plus cos inverse y is equal to, now this pi minus cos inverse z, we can write it as cos inverse of minus z using the property. Cos inverse of minus z is pi minus cos inverse of z. We want to prove that x square plus y square plus z square plus 2xyz equal to 1. See, there is no inverse function involved here, right? We simply have x square, y square, z square term. So we want to get rid of these inverse functions. So we'll consider, next step we'll consider cos of cos inverse x plus cos inverse y is equal to cos of cos inverse minus z using cos of a plus b, that is cos a cos b minus sin a sin b. So we get cos of cos inverse x cos a cos b, cos of cos inverse y, in between sign is minus, sin of cos inverse x, sin of cos inverse y, and right hand side is cos of cos inverse minus z is minus z. Therefore, now cos of cos inverse x is x, cos of cos inverse y is y, minus sin of, now this cos inverse x we want to write in terms of sin inverse. So this is nothing but sin inverse of root 1 minus x square. Similarly, second term sin of cos inverse y, you can write it as sin inverse of root 1 minus y square. Using trigonometric identity, you can easily prove this like the previous problem. Okay. Therefore, x into y minus, now this is nothing but root 1 minus x square. This is nothing but root 1 minus y square is equal to minus z. Therefore, now let's rearrange the terms. X, y plus z is equal to root 1 minus x square into root 1 minus y square. And now squaring both sides. So xy plus z whole square is equal to root 1 minus x square into root 1 minus y square whole square. Therefore, squaring both sides, so x square y square plus z square plus 2xyz is equal to 1 minus x square into 1 minus y square. Therefore, x square y square plus z square plus 2xyz is equal to 1 minus x square minus y square plus x square y square. Therefore, x square y square get cancelled. We get x square plus y square plus z square plus 2 times x y z is equal to 1. If tan inverse x plus tan inverse y plus tan inverse z is equal to pi by 2. Then prove that xy plus yz plus zx is equal to 1. Let's start. Given tan inverse x plus tan inverse y plus tan inverse z is equal to pi by 2. Therefore, tan inverse x plus tan inverse y is equal to pi by 2 minus tan inverse of z. Now, assuming that x into y is less than 1, we can write this as tan inverse of x plus y upon 1 minus xy is equal to pi by 2 minus tan inverse of z. Therefore, x plus y upon 1 minus xy can be written as tan of pi by 2 minus tan inverse of z. Now, using tan of pi by 2 minus theta is equal to cot theta. We get x plus y upon 1 minus xy is equal to cot theta is tan inverse of z. Therefore, x plus y upon 1 minus xy is equal to cot of. Now, this tan inverse z you can write it as cot inverse of 1 by z. Therefore, x plus y upon 1 minus xy is equal to 1 upon z. Cross multiply and simplify. So, z into x plus y is equal to 1 minus xy. Therefore, zx plus zy is 1 minus xy. Therefore, xy plus yz plus zx is equal to 1. So, we got the required result. xy plus yz plus zx is